Hi, my name is Brandon Graisley. We're going to learn about combinations, which is an extension of the idea of permutations. If you don't already know about permutations, you'll want to back up and learn about that first. With permutations, we're worried about arranging items, but with combinations, we are only going to be worried about choosing them, which means we don't care about the sequence that those items are placed in, only about which ones are chosen. So here I have three different examples. How many ways are there to choose a committee of 3 people from the 8-person student council? So 3 people are selected. There is no first, second, third person. They just end up in a group. The second example, how many ways are there to choose 2 songs from an album of 10 songs, if you're not worried about what order they're played in, for example. Number 3, how many ways are there to choose 5 questions to complete from an assignment with 8 questions? Now, this last one you might think of, well, there is a specific order, the first, then the third, then the fourth, and so on. And so in that case, the order, once again, doesn't matter, or you're not reordering them. You wouldn't want to count different orders of questions as different choices. So here's the big idea. If we were to use the permutations formula, we're going to end up with answers that are too big because we would count multiple arrangements of the same groups. So here's an example of, for that first question, we have 8 people and we're choosing 3 of them. Now this permutation formula would be to arrange 3 of them into a sequence, first, second, and third people. And that's 8 factorial over 8 minus 3 factorial, or that's 8 factorial over 5 factorial, 336. This is a very high number, too high for this situation. So here I've written down a specific example. Suppose Andrew, Bashir, and Cameron were all chosen for a group. The permutation formula would count that sequence, Andrew, then Bashir, then Cameron, as a separate arrangement from Bashir, then Cameron, then Andrew, but that isn't what we want. We want to count the different groups, not all of the different arrangements of those people. So here's how we adjust things. For every group of 3 people, we know that there are 6 ways to arrange those 3 people. That's 3 factorial, or P33. That means that the permutation formula is going to give an answer that is 6 times as big as the one that we want. So we can fix that because we can predict it. We can just divide the permutation formula by the factorial of the group size, by 3 factorial here. If we'd been choosing 4 people, we would have needed to divide by 4 factorial because there'd be 24 ways to rearrange them. So we're going to end up with a new formula. So the number of different groups of R items chosen from N unique items, so that would be like 3 people chosen from 8 people, is the following. Let me just scroll a little bit here. So we read this here as N choose R. It looks kind of like a fraction with no line in between. The one number is written above the other number, and you have to put these brackets around it. So it's kind of it's sort of tall looking, skinny brackets. That's N factorial on the top, the number of items you're choosing from. And on the bottom you have R factorial, that's the number of items chosen. In our last example that was 3 factorial. And then N minus R factorial. Now this first, the part that's on the kind of the right hand side, N factorial over N minus R factorial, that's the permutation formula. We just add in an additional division by R factorial. So once again, we call that N choose R. It's called a combination. There are a couple other ways to write it. You can see down on this line right here, NCR, or N choose R. And that's how you likely will see it on a calculator if you're looking for that button. Or sometimes you'll see CNR. That's kind of rare though. We don't usually use that one anymore. Most common is to use this one here that looks kind of like a fraction with no line. So once again, it's the permutation formula, but you also divide by the factorial of the size of the group you're choosing. So let's solve some of these questions all the way then. Here's example 1. How many ways are there to choose a committee of 3 people from the 8-person student council? We have 8 choose 3. That's 8 factorial over 3 factorial times 8 minus 3 factorial. You can simplify that bracketed bit there. 8 factorial over 3 factorial, 5 factorial. And once you work that all out, you get 56 different ways to choose the committee, a lot less than the 336 that the permutation formula would give us for different arrangements of 3 people. Our second example, how many ways are there to choose 2 songs from an album of 10 songs? So we write 10, choose 2. How many ways are there? 10, choose 2. That's 10 factorial over 2 factorial, and this works out to 8 factorial. That's 45. You'll notice that those two bottom numbers, 2 and 8, add up to 10. In the previous example, 3 plus 5 added up to 8. So we had 45 in this example. Sorry, I should finish that off. How many ways are there to choose 5 questions to complete from an assignment with 8 questions? Well, here we have 8, choose 5. That's 8 factorial divided by 5 factorial, 8 minus 5 factorial, which is 3 factorial. And we get that same answer, 56. And that's not a coincidence. You'll notice that choosing 5 out of 8 or choosing 3 out of 8 works out to the same thing. Those are just multiplied values, so it doesn't matter what order they're in, you're going to get the same answer at the end. And there's a good reason for this. Suppose you have 8 people. Let's go back to that very first example at the top. You have 8 people and you need to choose 3 of them. 3 people to form the committee. That is equivalent to choosing 5 people that are not on the committee. So selecting 3 to be on the committee is the same as selecting the other 5 to be excluded from the committee. All right, let me scroll back down here. And I have a little bit of practice for you to try, and then I have a few notes. So I want you to try each of these combinations. You can try writing them out with factorials, and then you can try evaluating them. I'm going to point out this last one though. You probably can't use the factorial buttons on your calculator because 80 and 79 are extremely large numbers when you take the factorial of 80 and 79 factorial. But instead you can use that NCR button and type that in. Usually type 80, then NCR, then 79. That's the sequence. In fact, I would recommend trying all of these with factorial buttons just to test it out and understand how it works, and then also evaluate them just using your combinations button, that NCR button. Now, once you're finished all that, then pause the video right now and do that. Once you're finished that, then I want to notice some cool things about the factorials, or sorry, the combinations, and you'll be able to look back at some of these questions to test it out and see those connections. So here are some things to notice. First of all, n choose 0 is always 1, no matter what n is. So if you had 8 people, how many ways can you choose none of them? Well, there's one way, the choice with nobody. It's not exactly 0. We always make it 1, and that's sort of like the 0 factorial rule. 0 factorial is 1, and n choose 0 is 1. N choose 1 is always n. If you had 8 people and you wanted to choose one of them, how many options do you have? Well, there are 8. So 8 choose 1 is 8, 10 choose 1 is 10, and so on. N is not allowed to be smaller than r. If you had 8 people, how many ways are there to choose 12? Well, that doesn't make sense. It's not possible to choose 12 people from a group of 8, so we just have a rule that it can't be smaller than r. They can be the same. You can do like 10 choose 10, and that's actually going to work out to be the same as 10 choose 0. So that leads me to this last, or second last idea, I guess. N choose r is the same as n choose n minus r. So for an example here, 10 choose 4 is the same value as 10 choose 6. That's similar to examples 1 and 3 that we did above, but it's always true, and this is the sort of algebraic way to write it out with n's and r's, the most general way. And the last kind of neat thing is that the middle r values, the ones that are closer to the middle of n, or the halfway value of n, those give bigger combinations. So 10 choose 5 is going to be bigger than 10 choose 4 or 10 choose 7. And it kind of makes like a little hill. The biggest, it starts off small, it gets big, and then it gets small again. And we already noted that it's symmetrical. We noted in this idea right here. So that it makes this nice sort of hill. And you can try that out with some smaller numbers. 10's actually kind of big, but maybe try it out with like all the 5 chooses or the 6 chooses and write them down and see how the patterns go. And if you're really interested, you could look up combinations and Pascal's triangle, and you'll see that there's a cool pattern that happens there as well. Okay, thanks.